Hello and welcome to another Math with Miss V video. This is solving one-step equations part 2. In this video, we will be using our knowledge of solving one-step equations with integers to solve one-step equations with rational numbers. Remember, a rational number is any number that can be written as a ratio of two integers. First, let's look at some decimal examples because decimals act like our integers do. They follow the same set of rules. So we're going to circle our variable and put in our line. We're going to undo addition with subtraction. The positive and a negative of the same number cancel. So C equals 6.7 minus 2.5 leaves us with 4.2. Let's look at the next example. So 1.2h equals 1.44. We are multiplying. We undo multiplication with division. We show division with the fraction bar. Multiplying and dividing by the same number cancels. 1.44 divided by 1.2 will give us 1.2. And for our last example, we undo division with multiplication. Multiplying and this dividing by the same number cancels. So we're left with R equals 2 times 2 is 4. 2 times 3 is 6. I have 2 decimal places, so my answer has 2 decimal places. And best math practices says to put a 0 when I don't have any whole numbers. Okay, so that's decimals. Let's talk about our friends fractions. They've got a little bit of a different situation. So if we are adding or subtracting, we treat it the same. We have the same rules, but we have to remember our fraction rules. So when we add or subtract, we have to find common denominators. In this video, we are not going to worry about dividing fractions. So if we have a variable divided by a fraction, that will be discussed in a much later video. Now, multiplication is where a few extra rules come into place. We know that multiplication is undone by division. We also know that when fractions are divided, we have to use keep, change, flip. So we keep the first number, change division into multiplication, and flip the second fraction over in order to work through our division. So to keep from doing extra work, we multiply a fraction by its reciprocal. So why do we do that? Let's look at an example of what happens when we multiply a fraction times its reciprocal, or the fraction flipped over. So 5/8, its reciprocal would be 8/5. Okay, so there's two ways we can look at that. We can go ahead and multiply and say we end up with 40/40, which equals 1. Or we can say 5/8 times 8/5. The 8's cancel each other out and make 1s. The 5's cancel each other out and make 1s. So we're left with 1/1 times 1/1. Which equals 1/1, which equals 1. So when we multiply by the reciprocal, we're getting rid of the fraction. We're turning it into a 1. And once we turn it into a 1, anything multiplied by 1 doesn't change. So we're back to the lazy positive 1 who likes to pretend he's there doing work, but he doesn't actually do any work to help us out. So this is why we will multiply fractions by reciprocals when they're being multiplied. So let's look at a few examples. Okay, so the first one is adding. We're going to treat that the same way. We undo addition with subtraction. So minus 2/3 minus 2/3. A positive and a negative of the same number cancel. So we have n equals. So these are different signs. They tell me to subtract. I'm going to check. My denominators are the same. So 2/3 minus 1/3 is 1/3. I have more negatives. So I get n equals negative 1/3. Our next example, put in our line, circle our variable. So I have a negative 3/4. The opposite of a negative is a positive. A positive and a negative of the same number cancel, so D equals. Okay, these are different denominators, but I can change a 1/2 into a 2/4. So now I have common denominators. 2 plus 3 is 5/4. And best math practices says turn this into a mixed number. 4 will go into 5 one time with 1 left over. So D equals 1 1/4. Okay, let's start looking at our multiplication, a little bit trickier. So we would, if we were to follow our rules of one-step equations, we would undo multiplication by dividing. But then we know with fractions, we have to use keep, change, flip, our fraction rule. And so we're back with turning division back into multiplication, but flipping the fraction over. So we're going to save a step. And we're going to multiply by the reciprocal, or the fraction flipped over. And remember, in our example, that this all cancels out and leaves us with a 1x. And we can write 1x, but we don't have to. 1x is just the same as x. So we're going to say x equals. I'm going to put my 10 over 1. Just to help me out, I'm going to simplify some at the beginning, because I know 2 and 10 are both divisible by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. 5 times 5 is 25. 1 times 1 is 1, but we don't have to keep a 1 in the denominator. I'm going to work 2 more exampple with fractions, just so you can get a very good idea of what's going on. So negative 3/7 u equals 21. I'm going to multiply by my reciprocal, so 7 over 3. And just like with whole numbers, it's going to take its negative with it. So times negative 7 over 3. Okay, these cancel. U equals, let's go ahead and simplify some, because I know 3 and 21 are both divisible by 3. 3 divided by 3 is 1. 21 divided by 3 is 7. 7 times negative 7 is negative 49. 1 times 1 is 1, but I don't need to keep a 1 in my denominator. In our last example, 2 fractions. Okay, here's my j, so I'm going to multiply by the reciprocal of the fraction with it, so 5 over 4. What I do to one side, I have to do to the other. These cancel. I'll put my line in just to keep it organized. So, can I simplify anything here? And I can. 6 and 4 are both divisible by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 3 times negative 5 is a negative 15. 22 times 2, or 11 times 2 is 22. And that's my final answer. So I hope this has helped you out solving one-step equations with our rational